Hello everyone, welcome to Pop Channel, where you can get the best video solution to past GCE question. Today we'll be looking at Additional Mathematics 2021 question 4, Mr. Table, right on.
June 2021. These are very important questions that we are going to look at today. Two questions, that's question 4 of 2021 and question 4 of 2022. So you shouldn't leave the hall without solving this question. The question says a binary operation star is defined over the set S 1, 2, 3, 4 as x star y is equals to x to the power y modulo 5. Then they say copy and complete the table. Then if you look at the first column here, 1, 2, 3, 4 are simply the elements of this set. If you look at this other first row here, 1, 2, 3, 4 are simply the sets that have been copied there. Then here, to get 1 here, for example, what they did is they took 1 star 1, which is the same as 1 to the power 1. 1 to the power 1 is 1. Then they take our 1 as the answer divided by 5. It goes 0, remainder 1. So here we have the 1. So to get this other value here, we take 1 here, star 2. So it becomes 1 star 2. And from the definition, it said x star y is equals to x to the power y. So x star y is equals to x1 star 2, which is equals to 1, which goes 0 times remainder 1 when divided by 5. So it means here we still have our 1. Now to fill the value here, we simply take 2 star 3 so that we have the value to place here. So we have 2 star 3. So if we do this rightly from the definition, it will give us 2 to the power 3. 2 to the power 3 is the same as 8. If we divide our 8 by 5, we are going to have 1 remainder 3. So the remainder is 3, so we write 3 here. And then to fill this other gap here, we are going to use 3 star 4. So we have 3 star 4, which gives us 3 to the power 4, which is the same as 81. Now 81 divided by 5, it gives us 16 remainder 1. So 16 remainder 1 is the same as 1 here. Then lastly, the empty space left here, we have 4 star 2, which is the same as 4 to the power 2, which is equals to 16. 16 divided by 5, it goes 3 remainder 1. So here we have 1. Then B part says give a reason why S does not form a group. And now they exempt this condition here, that assuming that associativity means that assuming that this set S under the operation star is associative, because associativity is one of the conditions to form a group. And this associativity simply means that if I take x star y, it should be the same as taking y star x. So they're saying that assuming that this condition is true, which other condition can we find from use from the table to show that this does not form a group? So if I look at the table, we discover there is no identity element. And how do we know that? We know that to get an identity element from the table, we need a row and a column in which the elements appear in order in which they appear here, in the order in which they appear in the set as 1, 2, 3, and 4. So we discover that here is possible. Here we have a column where we have 1, 2, 3, and 4. So now we needed to have another row in this direction, the horizontal direction, in which the elements will appear in this order. But you discover that there is none. So it means the element does not form a group because there is no identity element. Let's move on to the second part of the question, I2. They given the matrix M as 2, -1, -1, 2. Find the inverse of M. Now to get M inverse, what we use is 1 all over the determinant of M times adjoint of M. That means we are going to look for the determinant and also look for the adjoint. So determinant of m is simply equals to, we multiply the leading diagonal, means we have 2, -1, -1 and 2. We are simply going to multiply 2 times 2 minus -1 times -1. So it's going to give us 2 into 2 minus -1 into -1. We'll do this. We are going to have 4 minus 2 minus 1, sorry, which gives us 3. Then to get the adjoint of the matrix M, we just need to interchange the position of 2 and 2. Then this adds a negative here, multiply this by a negative, and also multiply this by a negative. So it means the adjoint of the matrix M is going to be 2. These two go up, this one come down, the same 2 remains here, then this one becomes 1 and 1. As such, our inverse now is equals to 1 on 3, all these times 2, 1, 1, 2, which gives us 2 on 3, 1 on 3, 1 on 3, and 2 on 3. Let's now move to the second part of the question. Remember, for you to better understand this, you need an exercise book and a paper, so you can follow up and try to solve with me. So you can usually post so that you can copy or take down short note for better understanding. Now we move to B. Find the point whose image is this under the transformation represented by the matrix M. So if we go back to, we discovered that our M inverse, which we just calculated, is equal to 2 on 3 and 2 on 3. This is our matrix inverse. Now, if we go back to the definition of transformation, we said if a matrix M transform a point A, for example, means M times A is going to give us A prime, where A prime is the image. Now they're telling us that if we have been given A, we should find the point M. So if we make A the subject, we are going to have multiply both sides by inverse. M inverse times M A is equals to M inverse A prime. If we do this, we discover that this one is going to cancel with this. We left with A now will be equal to M inverse times A. This implies that A will be equals to the inverse of the matrix 2 on 3, 1 on 3, 1 on 3, 2 on 3 times 5 -1. It equals to, to multiply this, we are going to have the row. The row here is going to plunge into the column. We have 2 on 3 times 5 plus 1 on 3 times -1. Then similarly, this row is going to plunge into the column. So you have 1 on 3 times 5 plus 2 on 3 times -1. If I do this correctly, I'm going to have 10 minus 1. That's 10 on 3 minus 1 on 3. And similarly, here I will have 5 on 3 minus 2 on 3. Since the denominators here are the same, we simply add the powers. So it means we are going to have 9 on 3, which is the same as 3. And here we are going to have 5 minus this 3 on 3, which is the same as 1. So our point is 3, 1, which was transformed to 5, -1 by the matrix M. Thanks for watching. Please don't forget to like and subscribe so that you can catch the next dropping video.